Hello, my name is Francisco Flamenco Andrade. I'm going to present my key activity. Does the temperature at which a helium balloon is exposed to affect its buoyancy? Justification. According to an article by the NPR, helium is the only element on Earth that is completely non-renewable. It is important that we consider how we utilize this element. And even when helium balloons' helium consumption is practically negligible, it is imperative that we be mindful of its usage and consumption by the public. Theoretical framework. Helium balloons float because the density of the gas inside the balloon is lesser than that of the air outside the balloon. This force is called buoyancy, and it has positive, upwards, neutral, and negative, downwards values. Buoyancy can be affected by density, which in turn is altered by temperature. As you can see by the image on the left, we can see that buoyancy, if it has a positive value, it has a lift greater than weight, and if it's neutral, it has a lift equal to weight, which means it stays in its place, and if it has a lift less than the weight or a negative buoyancy, it descends. Variables. During the course of this experiment, two variables will be measured: the buoyancy of the helium balloons and the temperature of the room where the balloons will be placed. Independent variable: temperature the balloons will be exposed to. Dependent variable: the buoyancy of the balloons. Methodology. In this video, I will explain step by step the data gathering process.
We put them in their respective places, so the temperature of them goes up or down. We'll have to measure them, their temperature, and their buoyancy. To measure their temperature, I have this thermometer, and its temperature, it's 29.6 Celsius, and the same for the other balloon. So now, to measure the buoyancy of each balloon, we'll use a weight with a spoon. We'll wait until it gets to 0, and we'll tie the balloon around. We'll first measure the spoon, so we can know its weight and take it off the buoyancy for the balloon. So we know that its weight is 37. So now we wrap the balloon around the spoon, and we measure the weight again. So now we know that the force of buoyancy in the balloon is at least 2 grams. And we do the same for the other balloon. They are around the same buoyancy, but we'll measure them just in case. The spoon is the same spoon, so we don't have to measure it twice. And again, it's 35. So we'll put this balloon in the fridge, where it will be cooled for some hours. And we'll check again so we can see if the buoyancy was changed. And this balloon will be left outside. And we'll measure again the temperature in a few hours so we can see what the difference is between the balloon that's cold and the balloon that's normal.
That was the video of the data gathering process, and now we will move on to the results. Here we can see the results, the time, and the first balloon, which was exposed to cold temperatures, and the second balloon, which was left at room temperature. The temperature was around 27 degrees on average for the balloon that was exposed to room temperature, and for the cold balloon, it was around -2 Celsius. So, keeping this in mind, we can see how the mass of each balloon measured with the spoon changed over time according to the temperature at which it was stored. From the data we obtained, we can infer that is that the temperature that the helium balloons are exposed to will affect its buoyancy. This is supported by scientific evidence, as the density of the helium is affected by its temperature. Thank you for your attention. This was my key activity.